Have you ever wondered why generating a high-quality AI image can feel like it takes forever? Part of the reason is that many of the most detailed models work sequentially, like a meticulous artist painting one tiny patch of a canvas at a time, where each new patch depends entirely on the one before it. This method, called autoregressive generation, produces beautiful results but is incredibly slow. While engineers have tried to speed this up by letting the AI paint a few patches at once, the speed gains have been modest. This paper asks a fascinating question. What if we could teach the AI to paint hundreds of patches at once, intelligently, without making a mess? The researchers introduce a new technique called Locality-aware Parallel Decoding, which completely rethinks the image generation workflow. Instead of a rigid, step-by-step process, they built a system that is flexible and massively parallel. The first key innovation is a new model architecture they call flexible parallelized autoregressive modeling. Think of it like giving the AI a set of magical flags, or position queries, that it can place anywhere on a blank canvas. These flags tell the model, generate a piece of the image right here. This allows the model to work on many different areas simultaneously. Critically, the system ensures that all the patches being generated in parallel can see each other. So a patch of sky being generated on the left knows that a treetop is being generated on the right, ensuring the final image is coherent. But generating in parallel isn't enough, you have to do it smartly. That's where their second idea, locality-aware generation ordering, comes in. This is a clever schedule that decides the best order to generate groups of patches. It prioritizes generating patches that have the most existing context to work with, like filling in the middle of a face after the eyes and nose are already there. This strategy minimizes errors and helps maintain the high quality we expect from top-tier models. The results are stunning. For a 256 by 256 image on the popular ImageNet dataset, they cut the number of generation steps from 256 down to just 20. For a larger 512 by 512 image, it went from 1024 steps to only 48. This translates to a system that is at least 3.4 times faster than previous parallel generation techniques, all while producing images of the same quality. Of course, the main challenge in this area is always balancing speed with quality. Pushing for too much parallelism can sometimes introduce subtle artifacts that a slower, more deliberate process would avoid. The researchers' intelligent ordering scheme is designed to fight this, but it highlights the fundamental trade-off. This work pushes the boundary of what's possible, moving us away from slow, sequential generation and toward dynamic, real-time creative tools. What new applications could be unlocked if an AI could generate a high-resolution image in the time it takes you to describe it? If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.